And so our next speaker, Dan and Dean are both from Portland, but our next speaker is from the Bay Area. And she's with, her name is Kirstin Weeks. She's an energy and building ecology specialist with Arup Consulting, which is an international firm. And she specializes in resource conservation and integration of ecological function in the built environment. Please help me welcome Kirstin Weeks.
Thanks everyone for being here. So as Tom mentioned, I'm with Arup, and if you're not familiar with Arup, we are a very large international engineering and consulting firm. But I don't know what that evokes with a lot of people, but we like to think of ourselves really as kind of the good guys amongst big international engineering firms, with all due respect to our colleagues at the other ones. Our motto is we shape a better world, and we're very serious about that. And we do it quite a bit with a sort of think globally, act locally approach. So we have skills networks that allow us to draw on our expertise from all of our other offices to focus on our local projects. So I'm in San Francisco. We have an office in Seattle. Someday maybe we'll have one in Portland. We'll see. We have lots of really wonderful colleagues at several different architecture firms here in Portland. In the green roof area, we do quite a bit of work designing and engineering green infrastructure of all kinds, including green roofs. We have a wide array of relevant engineering disciplines like civil, plumbing, structural, mechanical gets involved to some degree. But in addition to design, we've sort of, as engineers and scientists, we've taken a particular interest in green roof performance and being able to really say something with confidence to our clients about how the roof will actually perform and what it will contribute. And so we've had the good fortune to be involved with a couple of green roof cost-benefit studies in the last few years. One for Walmart, looking at green roofs versus white roofs and overall performance and cost-effectiveness. And then another for the US GSA. And that's mainly what I'm going to be focusing on today, the GSA study. But I will throw in some comparisons from the Walmart study as I go as well. And for both of those, we had a really wonderful team of collaborators, including Brad Bass, who's here today, Rob Brigage from Penn State, Charlie Miller from Roofscapes, Stuart Gaffin from Columbia on the GSA study, and then a great team of reviewers that included your own Tom Lipton for the GSA study. So I'll go through. Feel free to stop me and raise a hand and ask questions, and then I'm going to try to leave room at the end for questions as well. And if you'd let me know if I'm getting close to my time limit, that'd be great, because there's no clock on the computer screen. So the GSA study, it was actually mandated by Congress that this study occur. And I think the purpose was really to kind of decide whether, this wasn't stated, but I assume that the purpose was most likely to determine whether it was worthwhile to offer a federal level green roof incentive or a federal level policy, and also whether to continue an official policy with the GSA to install green roofs on their buildings. So it was a big review of all the scientific literature that we could find available on all different aspects of green roof performance. And then we did a model in-house. Some of our folks with financial background did a cost-benefit model to try to crunch the numbers and see how it worked out. So GSA has quite a number of green roofs going right now, but again, we weren't just looking at GSA roofs. We were looking at all roofs and trying to come up with a general case on the performance and financial case. So again, sort of a policy-oriented study. I should add Portland's 30 32 acres, I think I heard, to this. In setting up this cost-benefit analysis, the first step was, of course, to figure out what it was that we were comparing. So, and the costs of what and the benefits of what to whom. So the choice was made with the Gsa study to use, where's my pointer? To use just basically a black roof as the baseline and an extensive green roof or Ecoroof as the point of comparison. In addition to that, there's this question of who bears the costs and who accrues the benefits, and this was also an important point in Portland's study that was done back in 2005, right? 2008. So we did one calculation that looked at the cost-benefit equation for someone who's an owner-developer, someone else who's only a tenant of a building but not the owner, and then in addition for the broader community. These are all the different green roof benefits and points of savings or value that were analyzed. And what I'm going to do now is go through each one and talk a little bit about the benefits. I don't think I'll go into them in too much detail because I think people are pretty informed, and we also have some talks later on that will go into some detail about performance. But for each one, I'll note something about how we arrived at a number for that, a value number, and what those numbers were. And then I'll finish with the summary of the results. So stormwater is first for a reason. It turns out to be one of the most significant influencers on the financial picture for a green roof. We know that they can contribute to combined sewer overflow reduction, that they retain stormwater depending on the storm size and other conditions. We found in our literature review anywhere from 30% to 100% of the rainwater from a storm retained, permanently retained. The literature review was showing 1/2 to 3/4 of an inch. Our Walmart study was showing much, much higher numbers. It's a very large roof, so we were seeing 3.5 inches absorption, retention, not necessarily permanent, but there are a lot of interesting points on kind of design to maximize performance that I don't really have time to go into today, but would be happy to discuss with people later on. And then finally, the rate of runoff off the roof, around 65% seemed to be a typical number. I think in Portland, you guys found 56%. Walmart, it was more like 75%. Or sorry, 50 to 85%, depending on the storm size. So what does this translate to in terms of the bottom line? I would say the most significant cost-related factor is how much a building, a new builder, can reduce other stormwater infrastructure investments because the green roof is installed. That's probably the most significant potential savings, certainly on first cost, that someone has who's installing a green roof, particularly on a new building where the full suite of stormwater regulations has to be met. So we looked at for Walmart, and then we looked at other people's studies as well, but the Walmart study is probably one of the more extensive right now that looked at if you were to build, in their case, a store in 9 different cities in the country. If you built it with a green roof and you satisfied all your stormwater regulations and you received incentives if they were available, versus if you met the policies without a green roof, what's the difference in cost to you for building your whole store? And it ranged from the store with the green roof was basically it ranged from the green roof actually cost only 65% of what the sticker price was. So there was a 35% cost savings because of avoided infrastructure, all the way up to 100%. So the green roof paid for itself up front. And that actually, that higher end, we saw in cities like Portland in the combined sewer area. And the policy components that are important besides an incentive are things like that the green roof counts as pervious area and is not counted towards the stormwater calculation, or the green roof is able to satisfy the volume and quality and rate requirements of the policy. So that those kinds of things vary a lot by city. In addition to that, stormwater discharge fees can be reduced depending on the policy structure. And then, of course, when we go beyond the scale of the individual building to the city scale, we're looking at a lot of opportunity to reduce overall gray infrastructure. So heat islands and energy, I think everyone's pretty aware of the general benefits of green roof in this area: reduced heat islands, reduced summer and winter energy use. If the point of comparison is a dark roof like for the GSA study, the summer savings are much bigger than the winter savings. If the point of comparison is a white roof, Brad is going to talk later about what that means. But it shifts the balance a little, but we still see a savings. The peak energy loads, which are sometimes as important or more important than sort of overall energy use, also tend to be reduced. Middle of the day, the green roof, the thermal mass is reducing the energy use. And then a really important point that Brad will also talk about, so I won't go into too much, is that air intake temperature when you have rooftop mechanical equipment can also be moderated by green roofs. And then in addition to that, improved performance of PV is possible. So what does that mean in terms of annual savings? It depends a lot on the climate and the electricity versus gas rate structure in a place. But in the GSA study, the average of all the different, we had a range. The range in the GSA study was 4 cents a square foot to 22 cents a square foot in the year, and we arrived at 17 cents per year per square foot of roof as the typical. In addition to that, we calculated potential for community-wide energy and peak load reduction from the heat island effect reduction at 3 cents a square foot of roof per year. So that would accrue to the community rather than to the owner. And then in addition to that, potential for avoided costs at the power plant if the overall grid load is lower. Biodiversity and habitat, getting into things that are a little bit harder to put a number on, but that are maybe some of the most important things, really. Birds and invertebrates mimic natural habitats. We're pretty aware of this. But how do we value it? So there aren't a lot of schemes, a lot of standards right now. We looked to a system in Australia called the Bushbroker scheme, where new native planted areas or conservation of existing native planted areas can be traded for new development or can be just set aside for certain costs. And we came up with this 42 cents a square foot as a value for a biodiverse, in their case, it's only native plants, but habitat. So that's a pretty big number in the scheme of all this. Although probably still lower than the true value of the ecosystem services. Air quality and acoustics, another thing that's a bit challenging to value, but very important. So vegetation can capture particulates, absorb other air pollutants. The green roof can be a carbon sink, depending on the design and the way it's operated. And then in addition to that, acoustic insulation at the top of the building. So how did we come up with values for these things? The air quality benefit, there's a really wide range, anywhere from almost nothing to 60 cents a square foot that came up in different studies that we looked at. The acoustics was pretty challenging to put a number to. I think we didn't do it. We didn't include it in our analysis, but I'm sure that in certain areas people are willing to pay quite a bit to put in insulation against noise. several different things thrown together here: urban agriculture, jobs, and real estate values. So certainly there's some potential to produce saleable crops on roofs. Certainly there's lots of potential for green jobs. The real estate values I think are particularly interesting, and I have a catalog at the end if anyone's interested in exactly what we came up with for adjustments that would accrue to a developer. But there are the values to a developer, and those of us in here who are developers, I'm sure, are quite familiar with this, of just a bit faster full rental of a space, or a very small reduction in vacancies, or a slight increase in the sale price of a unit. These kinds of variables kind of blow a lot of the other things out of the water in terms of how much money they're actually worth to an owner. So even though it's hard to say in a definitive amount what a green roof does to those particular values, I think we can't ignore them. And just like with green building and as a whole, we have to, I think, sit with our clients or sit together and just come up with what we think is even a no-brainer. Like, at least you could agree that there's a certain percentage increase, and when we see the financial impacts of those small increases, they're quite significant. So what did we come up with? The agricultural crops we didn't assume because our point of comparison here is an eco-roof, and it's not a food-producing roof. You know, it's native planting, adapted planting, low maintenance. But that would be a good topic for another analysis. The real estate values I was talking about, with the increases in percentages that we came to, that were reviewed by a number of different, economic specialists, came to about $13 a square foot for all these different things: impact on rent, expenses, vacancy, discount, absorption, lease length, those sorts of things. So that's certainly sufficient to cover the first cost of a low to medium priced eco-roof. An additional, when we look at sort of how a piece of what a green building might do that might be attributable to having a green roof, we also came up with about a 2.5% increase in a sale premium for a building that we thought could be attributed to a green roof, particularly one that's occupiable. Quality of life and aesthetic value, another thing that's hard to measure. Access to views, access to outdoor space. We didn't throw this into our final analysis either, because there's so much debate over what it really should be, but some of the numbers we came up with, there was a study from Carnegie Mellon that showed access to just views of natural spaces. So these would be for lower roofs that you can see from an upper level, or roofs that you can see from a neighboring building. 2.9% productivity increase for people who are working in those buildings, and that is another figure that, for an owner-occupier, that kind of a number blows all these other numbers out of the water in terms of what it means to their bottom line. Green roofs can have a net present value of $12 a square foot due to these productivity increases and less absenteeism. If you're talking about a commercial business, that also could easily cover the first cost of a green roof. But like I said, in the final numbers I'm going to show you in a minute, it's not in there. So you'll see that the numbers are actually pretty conservative. And then finally, longevity of the roof. We're familiar, I think. Green roofs are protected. Green roofs protect the waterproof membrane. It's not exposed to expansion and contraction and people dropping tools on it, and therefore it lasts longer, and it requires less repair. So we came up with I think, 17 years as a number for a conventional roof, and that ranges quite a bit on the actual type of the roof, and then 40 for a green roof, which we think is pretty conservative also. So savings of 1 or 2 roof replacements. Oh, I'm sorry, I didn't mention our study was over a time horizon of 50 years. So when we talk about net present value, it's a discounted value over 50 years. Since it's a government study, we thought a long time horizon was appropriate. So the analysis, we did use a discount rate. It was 4%, I think. I have that at the end as well. So reasonably high discount rate for time value of money. And looked at these different relationships, like I said. We threw in the capital costs, the maintenance costs, which I'll go into here, replacement and disposal costs over that 50 years for every roof replacement, ongoing savings and value of all the different variables I just discussed, and it was over 50-year time horizon. So the costs that we came up with were, I think, pretty high compared with what we saw, at least for the Walmart study. They're lower. The Portland study, they're lower. So for Walmart, the first cost we were assuming is somewhere in the neighborhood of $11.50, including the membrane improvement and the structural upgrades. The range here was pretty big, but averaged, I think, $20 a square. Well, I guess here it's showing, I think we used the high end just to be conservative, so something around $20 a square foot, because we were looking at the 6-inch roof, and then somewhere between $575 and $1575, depending on if it's an all-in roof cost or just the overburden, is what you guys were showing in Portland. I think just $575 for the overburden on its own. And then maintenance costs are another thing that ranges hugely, from Walmart saying green roofs save us maintenance because we don't have to make small repairs, to the average for the GSA saying, oh no, they cost more, anywhere from 4 cents to 30 cents a square foot more each year. So what does all this add up to at a national level? If we look at a 10,000 square foot roof on a mid-rise building, we see the following. So the net present value over that whole 50-year period is that the installation, replacement, and maintenance costs altogether add up to about $17.50. The benefits from the stormwater benefits related to fees and first cost avoided infrastructure come to $14. So they almost offset each other right there. The stormwater is pretty close to offsetting the whole overall costs. We add in energy at $7 a square foot over that period, and we've bumped, we've broken even in terms of just an owner's individual bottom line. Then if we start looking towards community-related values and also things that there may be a market for in the future, like carbon dioxide, we came up with a $3 a square foot value in terms of CO2 reduction. Those real estate values I was just mentioning to you, so still just on the owner side for that, $13 a square foot. And then the community benefits, things like biodiversity, air quality, heat island reduction, are very big at $30 a square foot. And that's when, if you think back to Portland's incentive, for example, at $5 a square foot, you realize here, and knowing also that this is conservative, right? We mentioned all the things that we didn't actually throw into this analysis. If they're paying $5 a square foot as an incentive and getting $30 a square foot back in value, that's a really good deal for the city. And then a lot of people like to think in payback. So the simple payback here was around 15 years. And remember, the costs are pretty high, so it could be lower than that. The discounted payback, if you take the average annual savings over that 50 years and divide the first cost by that, it's only just over 6 years. But that includes things like savings on roof replacement that you don't actually see during that 6-year period. So it just depends how you like to think about your financial analysis. So then again, adding it up, if we think about someone who's only owning but not actually occupying the building, they do still break even, we think, but not by too much. An owner-occupier looks quite a bit better with a net present value of $6 a square foot, all in. So that's including the costs, right? It's not saying it costs 20, but the value is 6. It's you're up by 6 overall. For someone who's just a tenant of a building but not actually an owner, we think the net present value is $550, and then the community again $30 a square foot. And these are big ranges. I think it's really important to remember that every building is different, and this is one pass at giving an idea of what green roofs would do, but I think it should be thought of as plus or minus a lot, and it's really valuable to do location-specific and site-specific studies, organization-specific studies. One more slide just to look at kind of how sensitive the results are to all these different variables. If we have a slight change in any one of these variables, how does it change the overall net present value? So the longevity of the roof, what we assume for the lifespan of a conventional or a green roof, changes the results a lot. The installation costs also change the results a lot. So if the roof can be installed for a bit less, then the payback and the net present value go way up. The analysis is really sensitive to discounting too, so it's something people should keep in mind if you're sort of just dividing the costs by the benefits and not thinking about discounting the financial discounting. And if anyone's not familiar with that, it's just a rate to say that a dollar that you give to me in 5 years is not worth the same as a dollar you give to me now. I could be investing that or, using that over the 5 years. So we discount savings that occur in year 5 are not worth as much as savings that occur now. So whatever we use for that percentage does impact the results a lot, even more than all of the things that are below that. So it's a percent change in discount is more significant than a percent change in, say, energy savings. So you see all those other factors that are pretty significant as well. And that's it. And here's the team again that participated in this study, and I'd be happy to answer any questions or talk to people afterwards about it. Thank you.
So we do have a couple minutes for a question or two. Does anybody have a question they'd like to pose?
You talk about savings in storm drain installation, but don't you have to be able to handle these peak storms anyway? So can you really reduce the system? Another question I have is
Let's start with
you
the
save 35%, or you retain 35% of the storm water is what you tell me. But then I imagine there must be time where you actually have to irrigate and introduce water. So the amount of water you retain, is that lower or higher than the water you introduce? And the water you introduce, unlike the storm water, well, I don't know what the costs are here in Portland, but I can imagine that introducing water is costlier than disposing it.
Okay, so several different things. I'll start with your second question. I guess so. Depending on climate and plant selection, a lot of green roofs don't require irrigation. I know that here, the green roof on Tom's building is not irrigated at all during the rainy season, so you don't have a trade-off between, when the rain is coming and you're having to manage the storm water, you're not adding additional irrigation water. And then in the summer, if you're adding just a small amount of irrigation water, presumably you're managing it well enough that none of it's running off. You're just adding just what you need, a tiny bit. I think that the cost trade-off between buying water to apply for irrigation versus saving fees that you would be charged for disposing stormwater are different. I don't know. I think that equation would be different in different locations. I on a well-managed green roof with drought-tolerant plants, I can't imagine that the irrigation water would approach the savings in terms of stormwater reduction. But I suppose you could have a theoretical location where there were no stormwater fees and a high water price where that could, and a very, very long dry season where you might approach that. The Walmart roof that I mentioned in Chicago has no irrigation at all, so all those results are on a roof with no cost for irrigation, and it's functioning very well for stormwater management. So your first question was, what about the stormwater peak? And the field research that I've reviewed and been a part of have shown that green roofs actually are quite effective at reducing the stormwater peak. And it's going to depend on how big the peak is and what the green roof design is, but there are measures you can take in green roof design to make it more effective at holding and retaining the peak. And unlike an underground storm detention facility, the green roof actually has an ability to permanently eliminate some runoff from the total because it's evapotranspired from the roof, or it stays in the soil and then gets uptaken by the plants. It's going to depend on the roof design whether you need additional infrastructure. And some of the calculations that I'm talking about in terms of first cost savings with the green roof for the Walmart stores, they did still have to install something in terms of additional stormwater infrastructure, just not nearly as much as they would have had to install without the green roof. Does that answer your question?
It does, although I do have a couple of others.
Well, maybe we should see if anyone else does, and I'm happy to talk to you afterward.
Anybody else? Oh, there's, yes.
The installation costs in the study, do those costs include costs for, say, adapting any existing roof on an older structure to accommodate additional deadlines?
Some of them. Oh, sorry. Yeah. So the question is, do the costs include structural upgrades on existing buildings? And I would add to that, I would say yes, several of them do, some of them don't. Not every building requires a structural upgrade. Some buildings that are existing are overbuilt, or they had a different purpose, or they had a ballast on the roof that was very heavy that could be removed, and then the green roof replaces that. But yeah, several of these examples do, and even for new buildings, it's possible to quantify the if there's any structural addition, larger beams, more beams, joists, that sort of thing. It's possible to quantify what that costs. So on the Walmart study, for example, the cost for just the structural upgrade on their store was about $1.89 a square foot of the roof. So out of that $11.50, I think it was $3 a square foot for a better waterproof membrane, six something for the green roof overburden, and then $1.89 for structural. But it would vary by different buildings. All the time we have.
Yeah,
Yeah.
that's all the
Okay.
time we have. Thank you again.
Thanks.
So let's see. Oh, Matt's here.